Epidemiology in the Dock, Part 5. Let's look at their model for real. SEIR and SEIR aren't difficult models to understand. They just look scary because they're defined by several equations. The normal distribution is in fact scarier. Its formula really is difficult to understand. Note to censors, we use only government data. If you have a problem with the results, speak to the government. So we left off when we'd invented a system or set of differential equations for our cookie model. ds by dt equals minus fe. We also have dE by dt equals 0 and dF by dt equals 0. What? dE by dt equals 0. The number of cookies people eat per day doesn't change. dF by dt equals 0. The number of family members doesn't change over time. So ds by dt equals minus fe, dE by dt equals 0, dF by dt equals 0. A very simple model. And all it says is your family eats 24 equals 4 times 6 cookies a day. Now, wouldn't it have been simpler just to say that? Yes, it would. And wouldn't it have been simpler for Ferguson to say, everyone gets infected, 20% are serious enough to be cases and 1% die? Yes, it would, but someone might actually have stood up and said, everyone? How can it be everyone? Are you sure? And we wouldn't be in lockdown. But because the model said it, it must be true, even though that's all the model says every time. Don't believe me? Let's take a look. Here's the SI model from idmod.org. Great site, shame about the content. Not their fault, just the entire of epidemiologies. By now this should be starting to look familiar, but before you freak out for no reason, honest, let's put it into text and simplify it. Their version on the left, my version below. ds by dt equals minus bsi over n, di by dt equals bsi over n, and we can ignore the variant, is the same thing rephrased. Now what's the first thing you notice about this? ds by dt equals minus bsi over n, di by dt equals plus bsi over n. It's the same thing on the right, just with a minus sign. So it's really ds by dt equals minus a and di by dt equals a, where a is something. Now what's on the left? ds by dt, difference in susceptible, aka uninfected, per difference in unit time, aka how many people are no longer susceptible today because they got infected. Why couldn't they just say that? Well, di by dt, difference in infected per difference in unit time, aka how many people got infected today. Yeah, the language sucks, yeah? Seriously, maths is the most misunderstood world, and all because we use shorthand. It's like not understanding Russian or Greek or Chinese because they use funny letters or symbols. Recognize that? You eat there all the time. Let me take it out of Cyrillic. Restaurant. How about now? There are two sins of maths education. Memorizing, a waste of time almost and confusing, and shorthand, failing to emphasize that that's all it is. You think mathematically all the time. You just never learned the shorthand, in most cases. What happens if you're forced to memorize something and it is meaningless and you can't remember it? It puts you off, make you think it's not worth it or not fun. Einstein rode a light beam. Tell me that's not fun. And he changed the world forever. Imagination is true maths. The rest is just language and experience. Now we had ds by dt equals minus a and di by dt equals a, which says what? Susceptible, Jesus, whatever, goes down, and infected goes up. That's it. That's their model. Susceptible, whatever. Goes down, infected goes up. No, really? But how does it go down, up, master? Well, grasshopper, by BSI each time. But what is BSI, master? It's BS with an I, grasshopper. And never a truer word was spoken. B, or beta, is spread. What percentage of susceptibles to take and call infected? Basically, B. Yeah, that works. It's just a number, akin to the R0 that's been the biggest source of messed up non-science nonsense in this whole tragedy. So S is how many are left, the doomed victims yet to be infected. And they are doomed, as we'll see, because no one escapes the virus. Yup, absolutely true. The models say so. I is how many are infected, and N is the total population. So B is fixed, N is fixed, so they're constant, and let's call them capitals and leave them as such. S changes and I changes, so they're variable, and we'll make them lowercase s and I to indicate that. In the SI model, you're either S, susceptible, or I, infected. So N equals S plus I, you're either susceptible or infected. And in our lowercase for variables, that's N equals S plus I. Yep, big deal, I know. What does this BSI over N look like? Well, let's forget B for a moment and look at the dynamics of this. You've got S, the group, with S people left uninfected. To start with, S equals N, or N minus 1, because someone has to be infected, else it's a divine infection. And the one, the I, the one infected, the chosen one, and hell yes, religion is a virus, fake news is a virus, all news is a virus, we talk of things going viral all the time. Laughter is contagious, so is fear. The one I goes round high-fiving their mates, getting in close to tell them a story, and all the while, unseen, unheard, hordes of little micro-aliens are transferring to their unwitting victims, the susceptibles. And 3 of the hundreds of people that person got close to get infected. And what happened to all those others? Did they reject the virus? More on that anon. So S equals 100,000, say, or 99,999 now, because we have 1 infected, with N equals 100,000. And the 1 infects 3 out of hundreds. Doesn't sound like much, but oh my god, that's trebling every day. And COVID-19 only doubles every 5 days per Ferguson, to start with, sort of, if it was exponential. So one person, I, had access to 99999 susceptibles, S, and managed to infect 3. Or put another way, 1/100,000th of the population, the infected ones, had access to 99,999 susceptibles, S, and had a chance to infect them, and infected 3. 1 over 100,000 equals 1 over N equals I over N. 99,999 susceptibles equals S, the susceptibles. So I over N of the population had a chance to infect S susceptibles. If twice that number had a chance, then you'd expect twice the number of infected. So it's obviously multiplicative. I over N times S, or IS over N, or SI over N. Wow, family of 4, 6 cookies a day each. ds by dt equals minus fe equals minus 4 times 6 equals minus 24. ds by dt equals minus bsi over n equals 1/nth of the population trying to catch S escapees so far and catching 3 of them. 1 over n times S equals si over n. So we're most of the way there, and that's all it is. Now, what would 1 over n times S, aka Si over n, actually work out to be? 1 over n equals 1/100,000th times S, 999,999, but seriously fine, 100,000. So 1 over 100,000 times 100,000 equals 1. Actually 0.99999, like I said, 1. But they actually caught 3. So we need to multiply that by 3. Easy, add a bigger constant of 3. B for bigger equals 3. Now we have a formula that 1 bugger chased 999 beggars, and Bagora the bastard caught 3 beings, weak, but whatever. N equals 100,000, I equals 1, S equals 99999, B equals 3. BSI over N equals 3 times 1 times 99999 over 100,000 equals 3. And sure, you figure out how to catch 2.999997 or whatever, knock yourself out. Now notice, how many that person could catch was determined by observation long before it became a model. And you could have just said, hey, they catch 3, which of course is what all the fuss about R0 is about. which conveniently forgot that R0 was only a first number until months into the infection, i.e. now, they miraculously remember that it changes. Marvellous. A bit like false memes like exponential. A shame they didn't remember that R0 is good for the first day only, or first cycle, or first whatever you like. It was never exponential, and add R0 to the lie propagator toolkit. It doesn't matter if you could use a chainsaw responsibly or if you could use a knife responsibly to save a life. If there are plenty of people out there in power in charge of your lives who have no interest in using chainsaws and knives, power and the media responsibly. Get rid of chainsaws and knives, or get rid of politicians and big pharma. Easy decision. We still have trees that need trimming. We also have politicians and big pharma that need trimming. Hey, that gives me an idea. So yes, on day one, given that I, the one, the infected one, can infect 3 people by divine right, I go ahead and lo, 3 were infected. And on day 2, we, the infected ones, now 4, can infect 3 people by divine right, so we go ahead and lo, 12 were infected. And so it goes on, the mother of all exponential viruses. And guess what? Because there's so many people in our population, we don't have to slow down for ages. 12 infected last time, plus we, the infected, that's 16, so we can go forth and infect 3 times 16 equals 48, plus us, that's 64, and we go forth and infect 3 times 64 equals 192, plus us, that's 256. And notice, although the B, bigger, bugger, factor was 3, we're actually going up in total by 4 each time. 3 new plus us, the infected. So this really is the mother of all infected. Now let's look at this, and sure, by now you get that it really is really exponential, right? No need even to chart that. But here we have the essence of all SI, SIR, SEIR, SIS, you lose immunity, not a woman's virus, models. ds by dt equals minus bsi over n. How many will get today? You lose. di by dt equals bsi over n. How many will get today? We win. It's in all of them. It's core to the models, and it says we're coming for you, all of you. Just to confirm that, here's the we've got you drop in susceptibles for the core models. ds by dt equals in SI minus bsi over n. In SIR minus bsi over n. In SIRD minus bsi over n. In SEIR minus bsi over n. So the core of the model in each of these cases is identical, minus bsi over n. Once you've been got, you can be infected, recovered, deceased, exposed, infectious, recovered. But the bottom line is we got you, the virus got you, and in the same numbers and at the same rate. BSI over n or just BSI over n. How many have you got? So we really want to look at that expression. First rule of mathematics, simplify. What do we have with BSI over n? Well, it's 4 characters, 2 of which are constant, leaving 2 variables s and I, or s and I if I can persuade PowerPoint to leave the case alone. Can we get that down to 1? Sure. In the SI model, you're either susceptible, not infected yet, or infected. So indulge me with a little simple algebra for a second. N equals s plus I, so I equals n minus s, so bsi over n is also bs times n minus s over n. And bsn minus s over n is bsn over n minus bss over n equals bs minus bs s over n. Now b is just a constant, so we can remember we have it, but for simplicity in thinking about the order or size of this, we can just call it 1 for the moment. So we've got s minus s times s over n. Ferguson's b, if spread is equal to a power rate, was doubling every 5 days, or 1.15, so it's not a big deal, and it's only a scaling factor. Whatever the series S is, under b equals 1, multiply by b other to get the second series. Trivial. So, ds by dt, the new cases per day, new infected strictly, lost to the safe, actually not so safe, susceptibles. ds by dt equals minus bsi over n, so we want a close look at this bsi over n creature, which simplifies as s minus s times s over n. Now don't fade on me, this is simple stuff, just forget it's maths. It's really common sense, but yeah, we'll be using our shorthand. What are we looking for? Well, there are several things of interest. We've seen it looks and essentially is exponential on the charts. Why is that? Question 2. Is infection inevitable? If the answer to question 2 is yes, then it shows that we weren't wrong to say this is absurd. Even if you're in a hermetically sealed box on oxygen, it will still get you. If there's a ring of fire around the only infected person, it will get you. There's no escape. S minus S to the times S over N, so what can we observe? First, can it ever be negative? S isn't, it's a subset of N, and N is, by coincidence or not, also an N, a natural number, 0, 1, 2, 3, etc., non-negative. Now S over N, what about that? Well, it's less than or equal to 1. Think about it. You can't have negative susceptibles like you can't have negative numbers of people, and there aren't more people in the population than there are in the population. So S is less than or equal to N. What if S equals N? What does that mean? It means you've got 0 infected. What happens then? S minus etc. equals 0, or N equals 0. So in that case, S equals N, I equals 0, no infected, and ds by dt equals minus bsi over N equals bn0 over N equals 0. I.e., susceptibles don't change, no one gets the disease because there's no one to get it from. Makes sense. We've done that case, and now we can focus on S less than N. There are some infected I. What does some look like? Let's look at the extremes. I equals 1 and S equals 1, and S would be 999,999, and I would be 99999 in those cases. The first is at the start, one person infected. The second is at the end, one person left to get. S minus S to the times S over N, which simplifies to S into 1 minus S over N. Looks like 99,999 times 1 minus 999 over 100,000. Pretty damn close to 99999 times 1 minus 1. So it's going to be close to 0. Well, it is close to 0, but it's not 0. In fact, it's 1. So one infected person has now infected one other infected person, which is doubling in one day, so pretty aggressive. In fact, if we look at the chart and the figures, so yes, very aggressive, and rounded to 2 decimal places, that line goes up pretty much straight up, new infected doubling every day and total infected doubling every day. And it only nudges off 2.00 F on day 9. F is the ratio factor of new cases today versus new cases infected yesterday. And it looks a lot like 2, doubling with total infected also doubling until the virus is well established, and at day 10 it nudges below 2.00. But by now it's only 7 days away from peak, 25k infected per day, a quarter of the population in a single day. And at peak it's still growing, or grew, at 24% more cases on that day than the day previous. Then it plummets. Finally, the scarcity of new susceptibles, try saying that when you're pissed, susceptibles begins to bite, but it scarcely, so to speak, matters. Half the population is already infected. The next day, it will be 3/4 the day after that, 93%, and the day after that, 99%. 3 weeks and you're down to 2.79 hiding in cellars, and the next day they're gone too. It's truly a biblical plague, a hand of God sweeping through every corner of the nation. No one escapes, and that's the core term BSI over N in every model. And yes, it was clearly exponential until it didn't matter anymore. A few very low order decimal places off pure exponential. Thank God that's nothing like a real virus. But hey, firstly, I need to apologize. I realized, looking at my work table, that while I and di by dt were clearly exponential, that we're not seeing why that is from the ds by dt, so maybe I need to switch over to di by dt. The other thing though is Q2. Can anyone escape? Put another way, what does it take for BSI over N to be 0, at which point there are no new susceptibles taken, so any left escape? Now bear in mind we've been looking at the SI model where there's no recovery, which is deemed to be immune, else they'd go back to S and S would be increased. BSI over n in the SEIR model depends on I, and I reduces as people recover, so we need to look at that separately, one thing at a time. Does BSI ever hit 0, or when does it hit 0? B is a constant. If it was a 0, the disease would never spread. So trivial, fine, done, not an issue. Clearly doesn't apply to COVID-19. S is 100,000 minus 1 equals 99,999 on day 0, and when it hits 0, no one has escaped, so not very helpful. I equals 0. Well, it started at 1 and there's no recovery, so it never 0, so no. For B, S or I 0, they are trivial cases, no spread or no infected, or they are the no escape case, S equals 0. B, S and I can't be negative. Negative spread would be negative people infected, absurd, so they're all positive. So BSI over n is positive all the way up until finally S equals 0, and we're back to no escape. So the BSI over n term in the SI model says there's no escape, and it's exponential till it's so well established it'll be over in a few days. So how can we see that it's exponential? Let's take a look at it from the I perspective. My bad. di by dt equals BSI over n. Same thing then, but positive. And this time we're going to simplify for I. S equals n minus I, ignore b, set to 1 for convenience, and it's n minus 1 into I over n. Sorry, n minus I into I minus over n. So new infected equals n minus I into I over n, which looks like ni over n minus I over n, or I minus I over n, or I minus, well, I into I over n, or I times 1 minus 1 over n, sorry, I over n. Now this is rather easier to see how it's exponential. When I is small, I over n is basically 0, close enough to several decimal places. So we're basically looking at I new cases a day. So I cases gets I new cases, doubling. Yep, that's pretty exponential. And until I over n gets big enough to bite and take a chunk out of the new cases, it's going to keep looking exponential. Now, it's never truly pure exponential. If we show out to 5dp, we can see that it's never exactly 2 as a factor, but you can also see by adding a pure exponential red line that you can't even see the impure exponential of the SI model, as it's hidden behind the pure exponential, right the way to just before peak, a bit late then to start curling over a bit. So there you have the two big lies, or features, of the SI model, that contagion is exponential and nobody escapes. But that's not the most appropriate model for COVID-19, which would be the SEIR model, out past the SEIR model. But we've already seen the exponential and nobody escapes that emerge in the SEIR model, so we know we're going to be dealing with something very similar. And this has illustrated just where that fiction comes from. According to idmog.org, whose website is a model of clarity and excellent, herpes is an example appropriate to the SI model. So simple question for idmod.org and epidemiologists. If the SEI model models herpes and you put in our population and it grows exponentially and no one escapes, how come we didn't all have herpes a long time ago? The troll critics will say you're misusing the model. The trolls just say it snidely. But hey, that's why we're here. We're not the ones who took this no one escapes as exponential and used it to scare a population into lockdown and giving up democracy. If you want to lecture anybody on the proper use of this model, if there can be such, I'm finding so many flaws I doubt it, more and on, then by all means go and convince the original scientists and the 400 million people of the US, UK and Canada. For now, we'll leave it there. You've seen how the model naturally generates an exponential curve that only curls over right at the last minute, just like Gates said. It doesn't mean he doesn't have an agenda. It just means that he was quoting mainstream epidemiology when he said straight up and won't bend until the majority are infected. He's still in dock or under grave suspicion, ditto Ferguson, but now also are epidemiologists for putting their weight behind and trust in bad models that don't reflect reality. There aren't any new flaws from this slide per se, rather we've shown you the algebraic justification for what was obvious, the exponential and nobody escapes flaws. I'm Andrew Mather, a 60-year-old Brit, mathematician, financier, technologist, husband, piker, pilot, healer, whatever. Feel free to get in touch, andrew@peerlessreads.com or andrew@amather.com. Either should get to me.